It can be easily and efficiently converted from higher values to lower values and vice versa. That is one of the advantages of AC. Mean value means how much ever you have two currents. One is steady current, which means to say that a direct current, and the alternating current, which alternates regularly at certain intervals of time. Again, I have left out minus here, which I am including there. Again, I have minus cos omega 0. Omega into 0 is 0, so cos 0. Hello everyone, I am Vrinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to session 1 of chapter 7, and chapter name is Alternating Current. And here we are dealing with today with the introductory part as well as what is meant by alternating current, its advantages over DC, that is the direct current, as well as the mean value. Just the introductory part is in this session 1. So first of all, when we go to alternating current, in short, it is called as AC. AC means to say that it is alternating current. So in today's class, that is, we need to check what is DC and what is AC. DC means we call it as a direct current, and AC means to say that it is the alternating current. Alternating current. We have direct current and alternating current. So there are certain components which goes with respect to certain current. That is, one is with DC and one is with AC. Usually the resistor doesn't hold good for AC because the resistance has got the opposing component. Resistors are the one which gives the resist, that is, which resists the flow of charges within a circuit, because of which we call it as a resistors. So in case of this AC, resistor doesn't hold good, but DC, the resistor is applicable. But in case of AC, we go with inductor as well as capacitor holds good. So inductor as well as capacitor works in a good way or in a good behavior in case of alternating current, whereas it fails to work in case of direct current is the concept what you have to know. So in case of alternating current or alternating voltage, the actual source from where exactly we get this alternating concept is from generators as well as dynamo. It is from the generator or dynamos. Okay, so we have studied in electromagnetic induction chapter regarding the generator, that is how exactly the alternating current generator works. That is, for every half cycle, the current changes its direction. Direct current means, it means to say that the direction is steady. It has got a steady direction, because of which we call it as a steady current, either direct current or else even call it as a steady current. Whereas in case of alternating current, it alternates the direction, that is, it alters the direction, which means to say first half cycle if it is positive, the next half cycle it is negative. So this is said to be positive half cycle and this is said to be negative half cycle, but from here till here it is the complete cycle in certain time interval t, but at this point it is half the cycle, that is t by 2. Okay, so alternating current means it is the current which changes its direction, alters its direction. First half cycle is different and next half cycle is different in this case. So whenever you consider first half cycle said to be positive, next half cycle said to be negative, so the total cycle is considered to be 0, because the values which this include is equal to values which these include, but the values which these include will be positive with respect to this is negative. Positive of same magnitude and negative of same magnitude cancels each other, which gives you 0. Okay, so this is how exactly the alternating current is being mentioned. In case of alternating current, we have advantages over the DC. That means AC's advantage over DC, which means to say that it can be easily and efficiently converted from higher values to lower values and vice versa. That is one of the advantages of AC. And energy can be transmitted. E means it is said to be the energy can be transmitted over a longer distance, and it is said to be economic. Economically, it can be transferred to the longer distance. That is one of the application. And next we have, it can be converted to DC by a rectifier, and this is used in case of the mobile chargers, wherein your input is nearly 250 volts and your output will be in case of the 5 volt. Okay. Next is, it can be used in step up and step down, and that is done by transformer. All these about rectifiers and transformers you will study in the same chapter in the ending up classes. Okay. So these are all the advantages of AC over DC, which is very important for you to understand in general ways. Okay. So next we are getting on to the alternating voltage and alternating current. Usually the voltage is given by V and the current is given by I. Okay, we need to check the alternating voltage as well as alternating current in case of this alternating current circuit. Okay, so first of all, we have a diagram, that is axis, which gives the EMF or the voltage with respect to the time axis in case of x-axis. Since it is alternating current, it has to give such kind of a cycle where it continues. Here it is continued. Okay, this is a positive half cycle and this is said to be the negative half cycle, and the time period from this place to this place, that is the complete cycle, is said to be T. This is the end, and here the half of the cycle is T into half is T by 2. So this part is T by 2 is the concept. This is half cycle and this is full cycle. T by 2 plus T by 2 gives you just T. Okay, this is all about the sinusoidal wave representation of the alternating current. So we have an equation, that is instantaneous equation, instantaneous EMF or instantaneous current equations, which is given as, according to your electromagnetic induction last concepts which we had done in the last session, it had a concept of EMF, instantaneous EMF is equal to E naught sine omega T, or else even you can consider with respect to current, I is equal to I naught sine omega T. Out of this, let us study in detail what are these components. So EMF or I, this part is known as instantaneous values of EMF as well as current. Next we have E naught and I naught to be given as peak values. Peak values means maximum values. I'll show you where exactly this peak values arises. T means the time period which is taken, the two time periods which is taken, and omega, sine omega gives you the phase. It gives you the phase, and omega alone gives you the frequency. It gives the frequency. Okay, so out of which instantaneous values is a values at certain instant. Okay, peak value or the maximum value means this amplitude value is there. No, this can be either the peak values of EMF or peak values of current, which is as mentioned, this amplitudes are said to be the peak values, and which is said to be, since its amplitude at the peak is higher, we call it as maximum value. And sine omega concepts or cos omega concepts give the phase of the graphical representation, which means to say that it resembles the direction of it. Okay, and T means time period. At certain interval of time, how exactly the current is flowing is the time period which is given over there. So these two set of equation you will have to remember in case of the alternating current. So this is the equation or this is the formula for the instantaneous value of EMF in case of alternating current as well as current in case of alternating current. In the same way, we have voltage is equal to V naught sine omega t. That also comes under the voltage of this alternating current. So these are the three concepts what you will have to remember, and where you know t is nothing but the time period, so we always calculate for the half cycle, or full cycle means it will be t, half cycle means it will be t by 2, and omega, you know, it is the frequency, so you have 2 pi divided by t, where you know nu is equal to 1 by t. Here we calculate angular frequency, so it becomes angular frequency is equal to 2 pi nu. So this is the value of frequency, okay, and this is normal frequency which is equal to 1 by t. For we calculate for the angular frequency because it takes one cycle, one complete cycle, okay, one complete cycle, out of which the half of the cycle is said to be positive, the other half is said to be negative. So since it is taking up the angle, it rotates, it is taking an angle, we consider the angular frequency. It makes certain angle theta, so we consider it as angular frequency omega. So this is how exactly we go on with respect to the equations of instantaneous values of current, EMF as well as voltage. Having all these concepts as a basic term in this case, we just go on with the mean value or an average value of alternating current. In this, we study only about the expression, but here in this class, I'll tell you how exactly the value has come out, okay? So we have got the mean value of the alternating current, which means to say that according to the definition, mean value means how much ever you have two currents. One is steady current, which means to say that a direct current, and the alternating current, which alternates regularly at certain intervals of time. It gives the alternative direction. So the steady current, how much amount of steady current provides certain charge. That means in general, you know that a current produces, it sends certain charges within the circuit, okay. The current sends certain charge Q within the circuit at certain interval of time. The same value of current is being sent, that same value of current sends the charges Q within the circuit with certain interval of time, and both are equal, like in the sense this is by DC circuit and this is by AC circuit is the definition what exactly we study, which means to say that a steady current sends certain amount of charges through the circuit at certain interval of time is same, it is same as that of how exactly the alternate current sends the charges within that circuit in same interval of time. This is exactly the mean value, what you consider mean value or average value. That means to say that you have got an graphical representation in this manner, out of which you have a wave diagram like this, that is graphical representation of this alternating current, within which this shows EMF or current. So here that is time interval, positive curve and negative curve, okay. So this is the direction which is shown, and now there are n number of values over this curve here, okay, but we don't have a specific or a standard value. So in order to check the standard or specific value, we consider the mean value, which is called as a mean value, okay. Mean value means to say that you calculate all the currents at each and every intervals of time, and you just give one set of equation which is called as a mean value, okay. So how exactly you go on with that? You will have to remember only the conclusion part of it. But since you need to understand much more about this alternating current, I'll just give a integral part of this. That is, you already know that I is equal to, the current is nothing but the charge produced at certain interval of time, as we have considered in this. So we know that in order to calculate for each and every current which is present over here with respect to certain interval of time, a short method what we have is integrating it, okay. So integration means, integration you will have Q is equal to I into T brought together, and we have to integrate this in case of from 0th part to the T by 2 time interval. From here only half of the cycle we are calculating. From 0 to T by 2 we need to integrate this charge Q, okay. We know that the instantaneous value of current is nothing but I naught sine omega t is the one what we consider. So substitute in this, you have q is equal to integral of 0 to t by 2 and I is I naught sine omega t. Okay, I naught sine omega t, this t becomes dt because it is an integral change in time. For each current, there is time keeps on changing, right? That is why you give it as dt. So sine omega t into dt is the concept what we have. Now, on integrating, that means before integrating, we take I naught as constant because it is a peak value. Peak value is always said to be the constant peak value or maximum value, which we take it outside. So what remains is integration of 0 to t by 2 of sine omega t into dt. So we have q is equal to I naught, integrate sine omega t, you get minus of cos omega t divided by, we get it as omega and bracket close with respect to 0 and t by 2. Next we have q is equal to, you take I naught divided by omega towards other side, that is take it out. You have minus cos omega, substitute this, you have t by 2 minus cos omega into 0. So now when we just consider this complete thing, we have q is equal to I naught by omega and minus cos omega t by 2. We know that cos omega is, that is I'll write here itself, since you know omega is equal to 2 pi by t, I can go with this. I have cos 2 pi by t into t divided by 2. So t cancels, 2 cancels, minus, again I have left out minus here which I am including there. Again I have minus cos omega 0. Omega into 0 is 0. So cos 0. So which is equal to, q is equal to minus I naught omega, and I know that cos pi is nothing but, that is cos 180 degree is nothing but minus 1. Again I have cos 0 is 1. So I'll just equate this. I naught by omega, minus into minus is plus. So plus 1 and minus into minus is plus 1. So I have 2 I naught by omega and q over here. So charge q is equal to 2 into I naught by omega. So now on application for omega, since omega is equal to 2 pi divided by t is the time period, then I have q is equal to 2 into I naught divided by 2 pi into t. So 2 gets cancelled, so which is equal to, I'll have I naught divided by pi into t. So remembering this concept, now if I apply, that is I know that q is equal to I into t. So I consider this I as Im, that is the mean value, okay, mean value of the current, and t means it is t divided by 2. So now application to q. So substituting for q, I know that q is equal to I naught into t divided by pi. I naught into t divided by pi is equal to Im into t divided by 2. T and t gets cancelled, so what remains is I naught by pi is equal to Im by 2. I wanted the mean value, so I'll consider Im is equal to, I'll take 2 over here. So 2 into I naught divided by pi. 2 by pi value is Im is equal to 0.637 I naught. Okay, so Im is equal to 0.637 into I naught, which means to say that the mean value of the current is equal to 2 by pi times the peak value is the condition for this mean value or average value of alternating current. So this is what you have to remember, this as well as this equation. Okay, so that is all about the mean value or average value of alternating current, and in today's class we have studied what is meant by alternating current and direct current, what are the components which obey with the direct current and what are the components which obey with the alternating current, and advantages of alternating current with respect to the DC, that is the direct current, as well as we have studied the values, that is the instantaneous values and its peak values, how about the phase, angular frequency, all these things with the mean value or the average value, and how exactly to go on with the mean and average value is what we have studied in today's class. Let us all meet in our next session in the next upcoming classes of the same chapter. Until then, have a good day. Thank you.